Hi, geometry students. Here we are in chapter 1, and we're looking at section 4. We're going to talk about angle measure today. So our first vocabulary word that we're going to talk about today is ray. A ray is half of a line. It has an endpoint and it continues in one direction for infinity or forever and ever without stopping, right? And when we name a ray, it is important that we name it in order. So this would be ray A, C or AB or A anything else here. And I would write that with the symbol at the top, an arrow in a sense, and I'd write AB or AC. It's important that the endpoint is the starting point for your ray. Opposite rays, we could have this concept of opposite rays is basically when you take a line and you consider a point, let's say call this point T, and we can consider the fact that from point T, we have two rays here that are going in opposite directions. So point TR and ray TR and ray TS are opposite rays. And you'd write that TR and TS as rays like that. Okay, so next thing we're going to do is take a look at the concept of an angle. So what an angle really is you've got two rays that are not collinear, meaning they are not along the same line, and they have the same beginning point. So two non-collinear rays that have the same vertex or endpoint, or have the same endpoint, right? So let's call this endpoint E, and we'll call this, let's say, I don't know, D, and this one F. And so we've got ray ED and ray EF, and they're forming an angle. And so now the next several terms are going to relate kind of to this angle that we're going to look at. So let me make this a little bigger. Okay, so now let's take a look and talk about this first term. We've got the term side. So the sides of an angle would be the rays that make up the sides of the angle, right? So if I were going to talk about the sides of this particular angle, I would tell you that the sides of the angle would be ray ED and ray EF. Make sense? I hope so. All right, so rays ED and rays EF would be the sides of the angle. The vertex of the angle, the vertex of the angle. Vertex sometimes I call the elbow joint, right? It's like the bending place of the angle. So the vertex of the angle is E here. The vertex is going to be a point. It's point E. It's the elbow of the angle. Now when we talk about angles, we've got this idea that we can have an insideness of an angle and an outsideness of an angle. So if I'm considering this angle, I'm considering this section right here, I'm considering all this in terms of the angle. Everything that happens to be, I'm going to use this analogy again, but within the bending of the elbow, let's say this is truly an arm and it's bent, everything that is sitting on the arm or within the arm is part of the interior. So all in here is the interior. And of course, if you understand interior, you'll know that everything on the outside will be the exterior. So everything out here would be considered the exterior of the angle. So we've got this concept of degree. And degree is what we use to measure, is how we measure angles. What we're measuring is the opening of an angle. So degree refers to the way we measure an angle. And so a protractor, you've seen this before, a protractor is broken down, it's half of a circle, and it's broken down into 180 parts. And so a degree is basically when you take a full circle and you break it down into 360 even parts, and that is what 1 degree measures, 1/360th of a circle. Okay, so when we talk about degrees, we're usually referring to how we will measure the angle, the interior portion of an angle. That's degree. So now we have certain types of angles, and I'm going to draw pictures over here. Sometimes we have an angle that's called a right angle. A right angle is one that we're quite familiar with. Let me draw this nicely. Right angle looks like that. Not exactly. It looks something like this, and it measures 90 degrees. We'd be happy, or we'd be sad rather, if there were if our walls were not at right angles in our home. So most of the time we're used to the right angle measure in most things around our house or pictures and paintings, books, blah, 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 90 degrees. That's the angle that we like. All right, so those are right angles. Then we have angles whose interior measure is less than 90 degrees. And when you have that, these angles are so little, they are acute. They're so little and acute. Get it? Acute. Okay. We call them acute angles. And I like acute because little and all right, I'm done. So 90 degree, less than 90 degrees, we have acute angles. And greater than 90-degree angles, angles that are greater than 90 degrees are called obtuse angles. Obtuse angles. So we've got right angles, like them in our house, acute angles, so small and cute, and obtuse angles, greater than 90 degrees. So we're getting through this vocabulary really well. And now we've got this idea of an angle bisector. And basically, if you have any old angle and then some other angle comes along, some other ray rather comes along and splits that angle in half, such that the value on this side, let's say this is 51 degrees, and over here we've got 51 degrees as well. Once it splits the angle into two equivalent parts, once you have a ray that splits an angle into two equivalent parts, guess what that ray is called? It's called an angle bisector because it cut it in half. And now that we're done with our vocabulary, let's get started with some examples. So for this example, we're going to use the map of the high school shown in order to answer the following question. So here, part A, it says name all angles that have B as a vertex. So I go to B, I see that this is a vertex of a couple angles. Looks like this angle right here. So I can call that angle. Look at the symbol I use, a little L. Looks like a little kind of a fancy L like this. And I have A, B, D, and that's me referring to this angle right here. Notice that B is the vertex. It always goes in the center when I name it. I'm going to use three points to refer to an angle, and the vertex is always in the middle. Or I could actually use this number that is right there in the interior and call that angle 1. So that's two ways to refer to this angle, either ABD or angle 1. And now I can refer to this other angle that has B as a vertex as angle DB. Notice B is in the middle, C, or I can call it angle 2. Name the sides of angle 3. That's what we're doing in part B. So we go over to angle 3, and let me highlight it a little bit, help me keep focus on it. So here's angle 3. I'm highlighting it and I'm taking it. And when we talk about the sides of an angle, we know that the sides of an angle refer to the rays that create them. So angle 3 has C as a vertex. So I'm going to write ray CE and ray CB. Those are the sides of angle 3. All right, let's take a look at this one. What is another name for angle GHL? So we go to our diagram and we look for angle GHL, and we see it's here. Let's see if I can get this pen to work. So we see it's right here. And another name for it would be the value or the number that is right in the interior, right at that vertex, and that's angle 7. So we put angle 7 here. I'll write that neater, angle 7. That looks better. All right. So our final question in this section, let's go ahead and get this extraneous mark on. Our final question in this example is to name a point in the interior of angle DBK. So we go back to our diagram, we look for angle DBK. There's D. Let's mark it off. DBK is referring to this angle, right? And a point, let's see, name a point in the interior. A point in the interior would be E. There's a point that is inside of the angle. So the answer to that would be point E. There we go, point E. Let's look at the next example. Here in example 2, we're going to measure and classify angles. So we'll copy the diagram below and extend each ray and classify each angle as right. We know that's 90 degrees. acute, so little acute, less than 90 degrees, or obtuse, bigger or greater than 90 degrees. Then use a protractor to measure the angle to the nearest degree. Okay, so we've got the angle MJP. Let me highlight that. And there we go. We see angle MJP is located here. And we've got the telltale box here, which lets me know that indeed this is a right angle. The next thing we need to do according to this question here is that we need to measure this angle. And to measure the angle, we need a protractor. So I'm going to try this. I'm going to see if it works. I pulled this copy of the protractor from our textbook, and I'm going to see if I can drag it along to show you how to measure an angle. So what we're going to do is make sure that the little hole at the bottom of our protractor is exactly on the vertex of our angle. That's why I had to draw it so you can still see it when I move the protractor along. So we're going to put this point here right on the protractor, and we're going to line it up with the side 0. Sorry that there's still another angle here, but we're focusing on the black angle. All right, I did the best I could sliding this protractor picture right up on the black angle, and you'll notice that we're going to call this the initial side. The initial ray is at 0, and so I'm counting from this 0 portion. 0, I always start at 0. I see the 180, but you want to focus on 0. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and we confirmed that this is indeed a 90-degree angle. Let's look at this next example. So now we're checking out the angle LJP. So I'm going to highlight that like so. So we can see that clearly this angle isn't 90 degrees like MJP. It is greater than 90 degrees. And we know when we have an angle that's greater than 90 degrees, we call it obtuse. So this obtuse angle needs to be measured. Let's see if I can get that together. So I'm going to try to bring up our classroom protractor, or our textbook protractor rather. And I'm going to try to place it right on top of our picture here, like you should. So again, we make sure the vertex of the angle, and again, apologizing for this angle that's already there, we make sure the vertex of the angle lines up with the vertex of our angle, and that the straight side that goes to 0 is lining up with our initial ray, or the first ray that we're going to look at, or one of the sides of your angle. So I'm doing the best I can here. I've got it lined up. I think that's as good as it's going to get. You might be able to get a better angle measure. And again, I'm going to start with 0, making sure I don't start with 180 and start counting on the outside. I start with 0 and check that I'm going up 0, 10, 20, 30, 40, 50. And I'm going to stop at the end, at the last ray, or the last side of the angle. And we see that we're somewhere between 100 and 110. I would go with 105. So this angle for us, and for our measure here, is going to be 105 degrees. And here we are with angle NJP that I've highlighted in blue. We can see that it's less than the 90-degree angle, therefore it's an acute angle. And to measure that angle, we'll do what we did last time, lining up the vertex with the circle in my protractor, lining up one side with 0, counting from 0, and getting that this is approximately a 20-degree angle. So we've got 20 degrees there. This last example is a great example of what you need to do when you've got a lot of information and a figure. You want to write information right onto your figure when you can, not in your textbook if you're caring to preserve it. But anyway, so JK, we've got ray JK, KJ and KM are opposite angles. That means that's a straight line. KN bisects JKL. Here's JKL, and this bisects that. So we know that this angle is equal to this angle. Also, JKN is equal to 8x minus 13, and NKL is equal to 6x plus 11. We've got to find JKN. We want to know the measure here. Because this is an angle bisector, these two are equal, so I'm going to actually solve this equation. First, I get this. Then with a little bit more algebraic maneuvering, I get that x is equal to 12. But that's not what we were solving for. We want to find the measure of JKN, which means we need to take this x value, plug it back in order to evaluate. Substituting the 12 right there, I get 8 times 12 minus 13, which is 96 minus 13, which is 83. That's it for us. Talk to you soon.